Good morning, students. Today we'll start chapter Stability of Floating Bodies, which is in your section 3. So first of all, let us discuss the types of equilibrium. Generally, there are 3 types of equilibrium: stable equilibrium, unstable equilibrium, and neutral equilibriums. So let us discuss these types of equilibriums one by one. For this, let us consider this is a body which is floating in a liquid, and suppose this body is in equilibrium under the action of certain forces. Here the force is acting on the body. One of the forces weight of the body, which we have denoted by W, and it will act at the center of gravity of the body. Center of gravity of the body we have denoted by G. Another force is the force of buoyancy, which we have denoted by W1, and this force acts in the upward direction through the point H. H is the center of buoyancy. Center of buoyancy means the center of gravity of the liquid displaced. Now, suppose this body is slightly displaced from this position of equilibrium. Suppose this is a new position of the body when it is slightly displaced from the position of equilibrium. So the center of buoyancy, that will be shifted to some new position. So let us take H dash is the position of center of buoyancy in the new position of the body. Now, there are 3 possibilities. The forces acting on this body, they may tend to bring this body back to the original position, or they may tend to send the body farther from its original position, or the body remain in equilibrium in the displaced position. So we have the 3 possibilities. So if the forces acting on the body tends to bring the body back to the original position, in that case we say that the equilibrium is stable equilibrium. And if the body does not come to its original position, then in that case we say that the equilibrium is unstable. And in the third case, when the body remains in the equilibrium even in the displaced position, then we say that the equilibrium is neutral equilibrium. Now we discuss the case when the neutral equilibrium is possible. For example, if we give the body a small horizontal displacement without rotation, because in this case there is no horizontal force acting on the body, because there are only 2 forces acting on the body. One force is weight, which is acting vertically downward, and one is the buoyant force W1, which is acting vertically upward. So both the forces acting on the body, they are vertical forces. So there is no horizontal force acting on the body. So the body have no tendency to move horizontally, and hence the displacement for this body is 0. So we can say that the equilibrium is neutral in this case. Now, if we give the small rotational displacement which changes the shape, in that case the stability of the equilibrium, that depends upon the position of a point, and that point is called metacenter. So first of all, to discuss such kind of displacements, we will have to define metacenter. So what is metacenter? To define metacenter, let us consider a body which is floating in a liquid, and this is in the position of equilibrium. Let us take G is the center of gravity of the body, and H is the center of buoyancy. Now because the body is in equilibrium, and therefore the center of gravity and the center of buoyancy, they will lie in the same vertical line. So we can say that the line joining the points G and H, that will be a vertical line. Now, suppose this body is given a slight rotational displacement. So when it is given the rotational displacement, suppose this is the new position of the body. This rotational displacement is given in such a way that the mass of the liquid displaced remains unchanged. Let us take H dash is the new position of center of buoyancy in the displaced position. If we draw a vertical line to the point H dash, then the point of intersection M of the line joining the points G and H and the vertical line through H dash, that is called Metacentre. So the point M, which is joining the vertical through H dash and the line joining H and G. So this point is Metacentre. So we can say that Metacentre is the point of intersection of new line of action of the resultant thrust with old Hg. Old Hg, H is the center of buoyancy in the original position and G is the center of gravity of the body. Now, next we define what is plane of flotation. Plane of flotation, that is a plane or a line in which the horizontal surface of the fluid cuts the body floating in it. Suppose this is a fluid in which this body is floating. We can see that this is a line in which this free surface of the liquid is cutting the body floating in it. So here we can see that this line AB is the plane of flotation, or we can say that plane of flotation is the section of the body made by the plane surface of the liquid. Next we define the surface of buoyancy. Suppose we have a body floating in a homogeneous liquid and this body is displaced to a new position such that the volume of the liquid displaced remains unchanged. Here we can see that H dash is the new center of buoyancy. So if we consider all such positions for which the volume of the liquid displaced remains unchanged, then what will happen? We will have a center of buoyancy for each of the above displaced positions of the body. So the locus of these centers of buoyancy, that is called surface of buoyancy. So how can we define center of buoyancy? Center of buoyancy is the locus of the centers of buoyancies obtained when a body floating in a homogeneous liquid is displaced to all such positions for which volume of the liquid displaced remains constant.